So in this presentation, I'm going to give you an overview of the software that we are going to work on. So I have communicated this with Mr. Majduba. So he will be navigating the process of having this software available in your lab so that you can implement your algorithms and play with it and learn Python. And while you are learning Python, you can understand machine learning algorithms. So if your programming is reasonable and you can feasibly develop softwares using MATLAB or C++, so there is no difference if you are going to use Python. Only the scripting language structure is different, and you can start from the basics. So the representation of your data or your syntax is different for MATLAB, C++. So similar way, when you moved from C++ to MATLAB, you can easily navigate to Python. And from my personal experience, once I navigated to transition to Python, I have not gone back to MATLAB until and unless it is very necessary. So Python gives you a flexible platform, and there's a lot of help available on the web for implementing any algorithm that you are interested in. However, if you are more comfortable with MATLAB, you can code in your MATLAB platform. And to better understand, I would suggest that you first write a basic code in MATLAB and then convert that code into Python and then execute that code. So your transitioning from MATLAB will be faster. So this, for running your Python, I would suggest, there are different ways that you can do it, but I would suggest that you get your Pycharm Community Edition. It is open source, and you download this software and then import the libraries of TensorFlow, Keras, and related libraries with machine learning. Whatever you will use, you will get an error, and adding the libraries in Pycharm is very easy. So if some of your library is missing, you could simply add this. And importing your library is as simple as, for NumPy, for example, I'm going to import a library tool, NumPy as NP, and then for making the graphs, we have in MATLAB the matplotlib pyplot as PLT. And then we are using the linear regression module in sklearn. So you will add sklearn, automatically you will have your existing code for linear regression. For in the sklearn metrics, you will have existing mean squared error and R-square. So many functions and libraries are built in, and for this course you will be not developing from scratch, rather than using existing libraries and functions. Then we have sklearn preprocessing polynomial features. So you use this polynomial features to transform your data into any representation of your data. For example, for linear, then we have polynomial degree 2, degree 3, and it would automatically create your features, convert your features into that recommended type. So for starters, you will first download and install your Pycharm, and then you will create a new project, and then create the new project. Once you have created your new project, you are going to create a new file, and in the new file, you have different options. You can create a Python file, HTML file, you can create a resource bundle config file, but we are interested in Python file. So you will create a Python file. You will write the name polynomial regression. Here, this is polynomial regression. You will write that name and then simply save that file. So now I have saved this file in my Python project 1, the file name is, so whenever you're going to create a project, remember, you need to highlight this, then from this file you will choose new and then create a file. So if you are going to do here, then it will create a subfolder. So you need to focus which folder you are going to create your files. So we have this regression file, and this I have written the code for linear regression and polynomial regression degree 2. So initially we have the random data generated for x and y that is normally distributed. So this line for x, and then for y we are going to generate an equation x minus 2x square plus half x cube, and then we have the random normal. So this is your equation, and where x will range in the values 0 to 1, and you are going to generate 20 values, and then we are going to add random normal data to create finally your y. So this is just one representation of how you can generate your random data. Then what we are going to do is we are going to include the linear regression module, and we can see we are using the same equations, and we create x and y so that it includes another axis. So for linear regression function, you are going to fit the model that we are going to use is linear regression, and you are going to fit and we declare that, you can say we declare that with the model. This is the handle. So now model.fit will work on your x and y values, and then model.predict, model.fit, then model.predict will predict your y predicted values. Then it will create the scatter plot, and finally predict on the x-axis you will have your x predictor variable, and then you have on the y-axis you have the predicted. So now let's run. In order to run the code, you will go to the run window, and then you have this run. Here I have only created one file, Python file, .py file, but when you are working with your code you might have multiple files here, so you can select which file you want to run. So let's run this file. So now this is the first graph. It just plots your data. On the x-axis we have values from -5 to 5, and then on the y-axis we have the corresponding values. This is just x and y. So let's see what are these next two graphs. Next, what we are going to do is we are going to do linear regression on this data. So we have your x and y declared the same variables, and from -3 to 3 and 20 values total, and then polynomial features we have of degree 2, and then fit using this handle polynomial features dot fit transform of or x to get our x updated transformed polynomial variable, and then from using the linear regression existing model we already have included this using sklearn, and using the model dot fit we can now predict our values for x polynomial. And now here we are also calculating our root mean squared error between the existing y that we have here and now, or you can say from here, and then the x poly predicted, what our model predicted, and then calculate the score between them. And let's see what is the root mean squared error, and then just plot these values. So now we have, first we have the linear regression, the plot presentation, then we have our linear regression, and then we have our polynomial regression with degree 2. So let's now again run this code. So this is just a scatter plot of our data. Then using the existing libraries we estimate On the same data, we estimate the linear regression, and on the same data, we estimate the polynomial regression. And you can see the best fit line, it is changing. I will make this code available for you. The root mean squared error calculated was 10.12 and r-squared value is 0.85. 10 is a quite high root mean squared error. So we want to reduce the root mean squared error by using different models and see which one fits the best for this type of data. So this is a brief introduction of what I expect for you to learn in the first 1 to 3 weeks. So the main idea from this code, I will make this code available to you. The main idea from this code is for you to understand overall how we are going to create Python based code. What is the structure and syntax of your Python code? And then as an example, I will already provide you with this code, this py file, and you will run it on your Pycharm edition, community edition. You can download it freely at your home computers. And here I am using GPU RTX 3080, but of course if you don't have an RTX, even then your algorithm, machine learning algorithm, will work on a CPU based TensorFlow. So we need the TensorFlow, not right now for this assignment, but in the future you will be needing the TensorFlow libraries. So the TensorFlow, it can, or any machine learning algorithm, it can work on CPU and as well as on the GPU, but of course GPU is much faster as compared to your CPU. This is the brief introduction, and the target for giving you this code is to start